Since we've announced both Atlantis products and VSAN's been launched in the kind of software-defined storage and hyper-converged category, we've gotten tremendous interest in the products themselves as well as how VSAN and Atlantis work together, and we've been working closely with VMware to build joint solutions and add value on top of VSAN. So that's what we're going to talk about today. Before we get started, if you're not familiar with Atlantis, let me give you a little background on the company. First and foremost, products are 100% software. They're designed to be agnostic to the underlying server and storage hardware. In general, we have products that span desktop virtualization as well as server virtualization, and our key value is typically reducing the amount of storage that you need, delivering better performance at the storage level, as well as lowering risks and automating deployment and provisioning for systems. We are, well known for having the only in-memory storage platform, and what that means is that we're leveraging server RAM either as primary storage or the tier of storage to accelerate some underlying storage components and make applications run faster and virtual machines run faster. This is based on patent-pending technology that's in the area of I/O optimization, inline deduplication, compression, clustering, and other types of optimizations that we do at the server layer. We've got tremendous deployments, customer base. We sell our products worldwide. More than half of the company's revenue comes from outside the U.S., so we are truly a global company. We're deployed at some of the largest virtualization implementations in the world and have hundreds of mission-critical deployments at organizations in financial services and healthcare, government, across pretty much every vertical market. We have strategic relationships with the VMware in particular, as well as a lot of the leading server and storage and infrastructure vendors. And we've been awarded Best of VM Worlds, both in the US, in Europe, and have an award-winning solution. One of the things that we've been shipping products since 2009, and we've built a series of reference architectures, joint solutions around some of the leading products and vendors, including being a longtime partner with VMware, as well as some of their ecosystem partners across the server and storage space. So let's talk about kind of the problem and why why VSAN and Atlantis products exist. One of the issues today is that VMware was kind of a leader in virtualizing all of the server infrastructure, and by doing that, they increased the number of VMs that are in data centers today. So it became much easier to deploy servers. You get more servers running on per physical unit of compute hardware, and that led to VM sprawl and lots of virtual machines out there. Not to mention desktop virtualization emerging, and that is driving massive storage capacity growth. So, the numbers from analysts tend to be around 40% capacity growth per year on average, which means you're doubling your storage infrastructure every 2 years. And that's really something that's not a sustainable thing long term. The data center space required to do that, the cost of doing that, as well as the operational implications of doubling your storage infrastructure is difficult to deal with for many customers. So enter kind of software-defined data center concept. And while this is a buzzword, there are real values here, and it started with the compute layer. And over the last 10 years, we've been virtualizing servers to get pool and abstract CPU memory resources so that you could get more VMs and more workloads running, and better performance and better utilization out of physical server infrastructure. And that is, I think the latest numbers are something like 74% of servers are virtualized this year. So that's taken off, obviously. But storage has remained pretty stagnant over that time. There's been this disconnect between the virtualization of servers and storage being pooled and abstracted. So storage remains, very siloed, segmented, hardware-driven, and not really tied to the application, not as flexible as the virtualized server infrastructure. So now what we're doing with software-defined storage and within the construct of software-defined data center is trying to pool and abstract all of those storage resources to get more out of less hardware, and address that problem with customers' storage infrastructures growing out of control. Now, VSAN is an important kind of industry milestone in this, and the VSAN implementation, which we'll talk about in a minute, is focused on pooling and abstracting direct attached storage in a very specific way. But software-defined storage as a concept is broader than that and includes, pooling and abstraction of shared storage resources, as well as connecting that with, potentially with VSAN or other DAS type approaches. So I borrowed this slide from VMware, but before we start talking about VSAN, in case anybody's not familiar and hasn't read, the blogs or been exposed to VSAN, I wanted to do a quick introduction. Basically, what VSAN is doing is taking a combination of local SSDs or flash and local, typically spinning SAS drives or SATA drives, and creating a single storage volume out of that that's shared and presents to the application similar to what a SAN would look like to a virtualized application. Now, it's embedded in vSphere, which is great because you can reduce the resources required to do the pooling and aggregation of DAS. It's going to run on standard x86 servers, so there's an HCL for the x86 servers and disks that are supported. It's pooling the hard drives and the flash into a shared data store. The flash is being used as a caching or acceleration tier, and then it provides resiliency by replicating underlying blocks between nodes to be resilient to hardware failures. And then, of course, it's part of vSphere, so it's integrated into the entire VMware stack, so that you can take advantage of the single management and simplicity of using the vSphere hypervisor. Now, one of the things that's interesting is that this is an implementation of what people have started to call hypervisor converged or hyper-converged storage, which means that we're leveraging the disks and storage resources at the compute layer to present what looks to the application like a shared storage volume. So you're kind of separating out and moving away from this model of using a shared, physical separate box and moving into the storage is built into the compute layer, which we'll touch on more later. So how does Atlantis ILIO and VSAN work together? So Atlantis ILIO is, similar in that it runs at the hypervisor layer, so it's implemented as a virtual machine. And what it's doing is optimizing, accelerating, and also extending some of the capabilities of VSAN. So, for example, the optimizations that we provide will let you, do things like put up to 5 times more VMs on the same size VSAN, or reduce the number of disks that you need for a particular VSAN. We also are going to accelerate and improve performance in terms of IOPS and latency, so that you can, use it for different applications or applications that require, different performance characteristics. We'll increase the flexibility, meaning that, VSAN is, a hyper-converged architecture, but you still have shared storage. It would be nice if you could pool those two together into a single storage volume, and leverage existing investments in storage infrastructure alongside VSAN, as we transition to kind of more of a mixed environment with shared storage and converged architecture. Okay, so in terms of looking at kind of the VMware storage stack and some of the APIs, you can see Atlantis fits in there kind of as an optimization layer, delivering extra storage services, presenting different protocol options, and doing aggregation and pooling across areas that vSAN doesn't cover. So it fits nicely within the framework of VMware's multiple initiatives in terms of storage. So let's talk a little bit about what specifically Atlantis does. So first, we're going to accelerate and optimize any underlying storage. We do that by implementing a virtual machine that leverages server RAM on the host as either an acceleration tier, or in some cases it can be used as the primary storage. And as all of the I/O passes through our layer and VMs, we're doing inline deduplication, I/O optimization, compression, coalescing, we're thin provisioning everything automatically, as well as a number of other optimizations here. And this is really kind of the patented technology that Atlantis is bringing that's allowing us to do more, reduce the number of disks, get more VMs on a given unit of storage, as well as accelerate and deliver more IOPS and reduce latency. Now, another aspect of the platform is that we're able to create different types of storage architectures that are normally possible. So we can take some server RAM or server flash, existing SAN and NAS, and pool those and create the equivalent of like a hybrid storage array, but all in software, leveraging resources that are presented by vSphere. We can take a vSAN, accelerate and optimize it, or take existing local server resources that don't fit within the configuration that vSAN can aggregate, and pool those together and deliver a much more flexible hyperconverged architecture. We can take server memory and create a completely in-memory data store that provides tremendous performance that might be applied to a database, for example, or analytics. And then we can tie in and leverage cloud storage or hybrid storage models alongside any of those other configurations, all in a single platform. And then built into everything is this ability to automate deployment and configuration, to provision VMs very quickly, and then also to tie into orchestration systems, whether it's VCAC or one of the other orchestration systems through REST API implementation. So creation of data stores, getting metrics, configurations are all accessible via REST APIs. So in terms of, I wanted to give, focus a little bit, just what does it mean in terms of having all those optimization technologies? Well, what it means is you have Atlantis ILIO logically between the VMs that are running on the hypervisor and whatever the underlying storage is, which could be, vSAN or SAN NAS. And if you have this is a VDI example, but if you have, a certain amount of IOPS coming in that is a large amount at the hypervisor level, we're going to reduce that as it passes through the Atlantis layer. So this is, if you're thinking about, different software-defined storage approaches, this is a real difference, right? It's not just about pooling and aggregation, it's about optimizing, getting more out of what you pool and aggregate. So here, you're going to have up to 95% fewer blocks that are stored, fewer blocks that are traversing the network, fewer blocks that need to be replicated amongst the vSAN nodes. And then also you're going to be amplifying the underlying performance of whatever that storage may be. And in cases where you have very high performance storage, you can focus on, our optimizations focus on capacity reduction, so you can get more VMs onto that storage. In the case where you have slower performing storage, we're focused also on accelerating or amplifying the performance of that underlying storage resource. So let's talk a little bit more about how it's implemented. So we're taking a small amount of the underlying hypervisor's resources. We will have a VM that sits on a hypervisor where we're pooling that storage and where the VMs are running, and they will see the Atlantis ILIO virtual machine as the data store through the vSphere hypervisor. So we're actually using vSphere to present the data store to the VM. So it looks like any other data store, NFS, iSCSI, data store through vSphere. And then we're performing all of those optimizations on all of the I/O that's going through our layer, and then that's being stored on the whatever the hypervisor's data store is selected that our VM connects to. So we look like a VMDK on the underlying storage. Now, in terms of when you have different types of storage, so VSAN would appear like a SAN here, and then we're going to be tying into orchestration systems through those REST APIs, and then presenting a pooled data store up to the application layer with whatever protocol the application, the administrator wants to present to the application. Now, we have policy-based controls that allow you to deliver the right amount of capacity, the appropriate, performance characteristics, and then plan for availability in terms of failures of certain nodes, similar to, what VSAN has, but we have a few more options in terms of the different types of storage volumes you can present and how you tune the availability. And then from a storage services perspective, we add very fast cloning and provisioning capabilities. We have our own built-in high availability for our layer, as well as the ability to leverage high availability in vSphere. So how does this fit with vSAN? So there's a couple different scenarios here. One is we can layer on top of vSAN, and for us it looks like any other SAN, and then reduce the amount of disks and hardware resource that you need for a vSAN and provide acceleration and additional performance. Then we can also take an existing, virtualized infrastructure that is using shared storage and actually pool that across and extend vSAN to be in a pool with any file and block storage that you have that works with your hypervisor. So if you have, a NAS filer, a tier 1 SAN, you can pool that with a vSAN, or you can, use it in different ways and optimize both at the same time across both infrastructures. Okay, so let's talk a little bit about how this works for desktop virtualization. Atlantis, historically, a lot of our customers, we've just recently entered kind of the server virtualization market in February, and a lot of our 500 plus enterprise customers are desktop virtualization oriented, whether that's persistent, stateless, or XenApp/RDS type implementations. And we have a lot of experience in this, so we get a lot of questions from customers about what does vSAN and Atlantis together mean for desktop virtualization. So first thing to understand is that the desktop virtualization workload is very different from server virtualization, and how you benchmark and test and plan and size is completely different. You need to ensure consistent levels of performance with very inconsistent user behavior and patterns that aren't as predictable as servers. It's extremely write intensive, so during steady state, approximately 80% write, 20% read. It's got very small block sizes for 4K blocks, and it is one of those workloads that's very difficult to handle, and basically there's very little effectiveness in just kind of read caching of the underlying system that might be available in a storage array that works fine on the server side, but provides very little benefit on a desktop virtualization workload. So first thing to understand, desktop workload from a storage perspective is very different from the server workload. And you need to, the fact that it's 80% write means you need to plan storage very differently and size storage very differently. So now we did some joint benchmark testing with VMware. We've been a long-time VMware partner on the desktop virtualization side. It has many joint customers. So we wanted to kind of look at how we could use vSAN. So again, we have VMware View on top, or VMware Horizon View on top of Atlantis ILIO with vSAN as the underlying storage system. We did a test where we had a 3-node vSAN with pretty standard hardware in terms of what we see at customer sites, dual socket, 384 gigs of RAM, and we used one SSD and one terabyte SAS disk with 10 gig networking. And the Atlantis ILIO in this case was deployed on each of the 3 physical hosts. So there's 1 VM per physical host with 1 vCPU reserved, 1 vCPU allocated, so shared with the desktops. So basically you're consuming the resource of 1 vCPU from a compute perspective, which in this case I think was 1/16 of the CPU. And a total of 100 gigs of RAM across all 3 nodes. So that's also a relatively small percentage there. What we found is that the joint solution was very attractive compared to traditional SAN and NAS in terms of delivering performance. So we had 117,000 IOPS with 80% write, 3.4 milliseconds latency. We did a large boot storm very quickly, very good desktop user experience scores from PassMark. We'll get into each of those here. So just to give you an idea of what the impact of Atlantis had on so we did testing of the same exact configuration before Atlantis, and then with vSAN plus Atlantis ILIO working with it. So you can see that we went up 4 to 5 times in the total IOPS from about 25,000, which is actually a very good number on a 3-node cluster, to 117,000 IOPS. This is, just so if you're comparing this to other benchmarks, this is a very difficult workload, so you would expect numbers to be significantly lower here because we're talking 80% write, 80% random 4K blocks, which is the standard that we use in terms of benchmarking for desktop virtualization workloads. So server virtualization workloads might be significantly different. We actually have a great blog on this topic if you want to do your own testing on different storage infrastructure at blog.atlantiscomputing.com. There's a blog by Jim Moyle on iometer that actually has sample test files for iometer as well as details on best practices for doing this kind of benchmarking. The other thing that's also really key is latency. So, you have IOPS, input output per second, which is kind of the total number of blocks that you can exchange with the storage system on an input and output basis. And then you have latency, which is basically the time to get to the storage system and back, or commit a unique write, or read a block. Is that time, or that response time is latency. And both things have to have good performance to deliver a good user experience in desktop virtualization. So here you can see there was tremendous reductions in both average and maximum latency. So you can see the benefit in terms of the acceleration that Atlantis is providing here. Bootstorm test, so this is kind of a standard benchmarking test that's easy to do. We did 375 Windows 7 virtual desktops across the 3 nodes, and we were able to boot all of them to the point where the VMware tools were available on all desktops, which is actually a higher bar than just the login screen being open. And it took 6 minutes to do that, which is less than a second per VM. And a single Windows 7 desktop boot in that environment with all the other systems running is about 12 seconds. Okay, now PassMark. This is an interesting one, a little bit less known than iometer or perhaps like a login VSI type test. But it's interesting because the premise of it is that you're comparing to a very large database of physical PC benchmarks. And we ran what's called the disk mark test, which is a disk performance test. And I wanted to compare this with a couple of different scenarios for you. One is we did a virtual desktop with which used vSphere resource allocation to limit the desktop to only have access to 50 IOPS. So this is a control within the hypervisor that you can implement. And this is interesting because when you deploy virtual desktops at scale, people often test, with a single server on a big SAN, and performance is great. But then when you get up to, 3,000, 4,000, 5,000 users, you're sharing a very limited number of IOPS with across the entire user base, and you're really only getting, 5, 10, 20 IOPS per desktop, which is only a fraction of what a physical PC has. So physical PC might have 80 to 150 with a normal 7,200 RPM SATA drive. So here, by limiting to this 50, we're kind of simulating a very high, trying to get a high density onto a traditional SAN or NAS. So what you can see is that the score here on the PassMark index is 16.7, which is very low. Now, when we did that same test on a vSAN, it was, very good, faster than a physical PC 7,200 RPM drive. So, this shows that kind of the vSAN versus a typical SAN independently is, providing good performance. Now, when you add vSAN with Atlantis ILIO, we're talking 6,795, and this is kind of up there with the fastest benchmarks ever recorded, which you'll see in a second. So we're actually, increasing the score on this by, 6x or more. So you can see this is a direct, benchmark of what the actual hard drive of a virtual desktop's performance is. So you're going from equivalent of like a spinning disk speed to the equivalent of a PCI flash on a physical PC. So if you look at it, I had some problems getting the 17 to even show up as a bar there. So we put some labels on it, but this is a summary of what you just saw. Now, what's interesting is PassMark actually posts there's a high-end drive and a medium drive and drive list, and you can see that this vSAN plus ILIO is actually amongst physical PCs with very fast hard drives is the 10th fastest ever recorded on the benchmark. So you can see we're fitting in here, and we have PCIe flash cards that are ranking slower than the combination of Atlantis with vSAN. Okay, capacity reduction. So this is, because Atlantis has very effective deduplication and compression, and these are through, 375, identical machines, you're going to get, tremendous capacity reduction because there's very little unique data in it. So kind of the 99%, that's great, but it gives you an idea of it. But, in terms of capacity, we see in desktop virtualization 85 to 90% in production with unique data in the images. And that's, fairly consistent. We have lots of case studies that show that. So just to give you an idea on the capacity reduction, both at a kind of benchmarking lab level as well as in, expected in production. Okay, so I wanted to give you an example of what this means in terms of a, let's take a typical 500 user persistent VDI example with a 50 gig image. So if you were to design a SAN to deliver 50 IOPS per desktop, and remember that's less than a physical PC with a 7,200 RPM drive user experience, but fairly high in the world of VDI in terms of what people design for. 6 nodes, kind of an average production density that we see out there, 84, we typically see between 80 and 100 VMs. Some are as low as 30, so we picked kind of a middle density there. Storage configuration with RAID 1.0 or something that has a 2x write penalty. And if you do this math with 80% writes, you're talking you need 25,000 IOPS. It's going to take 281 15K SAS drives to deliver that many IOPS. Now, customers very frequently deploy fewer than that for that number. However, when they get up to scale, they will see performance issues. And if you're delivering 10 IOPS per desktop, you're going to hit a wall, and users will not want to use VDI. Now, with vSAN alone, this is significantly reduced, right? We use some of the benchmarks that we did, and we would see something like 60 to 80 IOPS per desktop, which is pretty good, better than a SAN and lower cost for that. We have a vSAN configuration with 6 nodes that we use with 2 failure nodes as an example, and 24 10K SAS drives per node, which means that you would have 144 SAS disks. So you have a significant reduction, better performance, and you are buying some flash there for acceleration as well. So a definite improvement. Then if you talk about vSAN with Atlantis, we're going to if you look at the IOPS, we're going to deliver kind of an average of more than 300 IOPS per desktop, and the ability to burst to thousands of IOPS per desktop when needed. And that ability to burst is actually just as important as the average number there. Same vSAN configuration, except here we can deliver the equivalent logical storage with 4 instead of 24 drives. So that means your total number of disks gets reduced down to 24 disks in this configuration, and a similar reduction in the amount of flash needed. Now, in some configurations, an interesting thing that's come up with customers that they've been very interested in is we could actually make it possible, depending on the drive sizes and the image sizes of the customer, to do persistent VDI with vSAN and Atlantis on a blade, which is not really possible, or people haven't thought is possible today. So that's been interesting, because if we're talking, especially the larger environments, a big percentage of the customers are have a preference for blade servers. So making that possible has good value. Okay, so in summary, the Atlantis is an award-winning solution. We've been working with VMware extensively on adding value to the vSAN architecture. I think we've showed you some benchmark and test results today that prove that. We've been proven at very large scale with deployments up to 100,000 users in a single customer. We've had, we have hundreds of mission-critical customers deployed in production. And we have some of the top minds in terms of virtualization expertise and implementing. And kind of the objective of what we're doing here is to try and allow customers to do more with their existing storage, improve efficiency, and deliver more performance to their applications and VMs with less underlying storage hardware. With that, I'll take a few questions. Carrie can maybe read a couple of the questions that came in. And if we don't get to your question, we can follow up with you independently after the webinar.
Thanks, Seth. Our first question from the audience is there a limit to the number of storage resources that can be used to create an Atlantis ILIO USX storage volume?
So in terms of the number of resources, so we view like a vSAN, for example, would be one resource. There is no theoretical limit. We've tested to 200 independent storage resources being aggregated and pooled. So no, there's not really a limit. And and VSAN would be presented as one storage resource in the pool.
Thank you. Our next question is there a minimum network requirement?
Good question. So any hyper-converged architecture, which means you're using, especially with VSAN, you're going to be replicating data across between nodes over the network, and the speed and bandwidth and throughput of your network will have an impact on the performance of the system. So we recommend 10 gig networking for any kind of hyper-converged implementation.
Okay. Thanks, Seth. Our next question is, do I need specific hardware to run Atlantis ILIO USX?
So no, you don't need specific hardware. The way it works is that we are implemented as a virtual machine, which means that any hardware that works with the underlying hypervisor and vSphere in this case. So if it's on the vSphere HCL, it will work with Atlantis. So you can do any file block, local flash, server RAM, SAN and NAS, all will work in terms of being pooled and aggregated through vSphere.
Okay. Our next question is, what is your protection for data and RAM in case of server failure?
So much like VSAN does protection between different nodes, we're going to be doing replication and data protection between nodes of the in-memory storage. So if we're taking, in the case of the VSAN implementation, we will be pooling and aggregating RAM between a certain number of hosts, and then all of the underlying I/O, and using that to front-end and accelerate VSAN. So as the I/O goes into the pool, and after it's optimized, it will be replicated between nodes for data protection.
Great. Do you support Hyper-V hypervisors?
Currently, we only support vSphere on the server side. We do support multiple hypervisors for desktop virtualization, and plan to remain hypervisor agnostic, but work with partners like VMware to build in integration for vSphere. Sure. So go ahead, Carrie.
Okay. How does ILIO complement or improve the features and performance of all flash storage appliances that can deliver an average latency of less than 1 ms over 200K IOPS?
So actually, that's a good question. We do actually have a lot of partnerships with flash storage vendors, and in that context, as I mentioned before, the implementation of how you design Atlantis ILIO's platform and what optimization we do will depend on the underlying storage hardware. So in the case of very high performance shared flash arrays, like maybe an IBM flash systems, for example, we have a partnership there where our optimization is all about getting more VMs onto that flash system array. So for example, if each VM was 50 gigabytes in the example we used before, you could get a very limited number on a 10, 20, 30, or 40 terabyte flash array. But with Atlantis reducing that capacity by 85 or 90%, you can get comparable performance with much higher density, which reduces cost.
Okay. What does the data look like on disk? I'm thinking it will require ILIO to interpret the content.
Yeah, so the Atlantis ILIO basically has a file system which is encapsulated as a virtual machine. So what it looks like on disk is you have a VMDK on disk which contains all the blocks that make up whatever the VMs are that are running on the Atlantis ILIO data store. Now, from the data store level and from vSphere, you can see all of the underlying files, and you can do things like storage vMotion on and off of that data store, to migrate something on or off or insert into an existing implementation. So, for example, if you were going to take an existing implementation where you had Tier 1 SAN and you wanted to pool that with a vSAN, and you wanted to put Atlantis on top of it to optimize it, what you would do is you would create the VMs and pool the resources and create the data store for Atlantis, and then you would storage migrate or storage vMotion the VMs from the Tier 1 SAN onto the Atlantis data store, and then that would distribute between the vSAN and that same SAN on the back end. So you can use, the files are visible at a hypervisor level, and then what it looks like at a storage array level is that it's a VMDK that contains all of that.
Okay, our next question is, how does ILIO control and maintain high IOPS and low latency through application read and writes that have variable block sizes beyond 4K?
Well, when I mentioned 4K blocks, that was because a large amount of 4K blocks are present in a desktop virtualization scenario. So we don't have any specific, we will handle many different block sizes and maintain low latency and high performance. It's not specific to or optimized purely for a 4K block. Next question looks like we have, for persistent desktops, do we need link clone from VMware View? So typically in a persistent desktop implementation, you're not using link clones, although it is possible. Typically the link clone type approach is used in a stateless or non-persistent virtual desktop. Now for persistent virtual desktops, Atlantis has a cloning function called Atlantis ILIO Fast Clone that only takes a few seconds to clone very large VMs, because you're not making, you're optimizing and not having to make a copy of all of the blocks. It's just handled in metadata. So that function is also exposed through VAI, so that if you're using View Composer, you can create a link clone, and then under the covers it's creating an Atlantis ILIO Fast Clone. But for persistent, you're typically not using link clone, you're just creating full clones of the virtual desktops. There's a question about trial version or evaluation. We have a evaluation request form on the website. We'll be opening up access to trial versions of various Atlantis products shortly. Okay, I think we've answered quite a few questions, so thank you for attending, and I think, Carrie, do you have anything to wrap up with?
Thank you, Seth, and thank you to all the attendees today. Again, I will be sending out the recording of today's session tomorrow, so please look out for that in your inboxes. We hope to see you on our next webinar, and have a great day.